Scientists at the University of Warwick have discovered a planet which shows potential to support human life. NASA released this image comparing it to Earth's size.
Minutes ago, the James Webb telescope found a new planet that might be better than Earth for life. We once thought these planets were all ice, but many actually have hidden oceans. Imagine this. 1 in every 5 stars has a planet just right for life, not too hot or too cold. The new planet, called Glea 163c, sits in the perfect spot near its star where it might support life. Let us uncover the mystery of Glea 163c, a planet in the perfect spot for life. Or maybe something far more unsettling, something we never saw coming, a planet where life might be possible. It was once believed that planets beyond Earth were barren, frozen realms devoid of life and water. This perception changed dramatically with the discovery of oceans hidden beneath the icy exteriors of some planets. It is now understood that approximately 1 in every 5 stars hosts a planet that could potentially support life, offering conditions that are neither too hot nor too cold and are just the right size. These planets boast both water and land, providing all the necessary components for life. As scientists explore space, they are close to a big find. On a planet like ours, they've picked up strange signals, suggesting we might not be alone. Beyond the confines of our solar system, the universe reveals a rich array of such planets, each offering a window into the immense complexities of space. During explorations, a strange signal was detected emanating from the depths of space, hinting at the possibility of existing, undiscovered forms of communication or life. This intriguing discovery suggested that the universe might be more populated and diverse than previously imagined. The arrival of the James Webb Space Telescope marked a significant advancement in the search for Earth-like planets. This state-of-the-art observatory uses infrared light to penetrate deep into space, revolutionizing the hunt for distant worlds. Among its numerous discoveries, the exoplanet Glea 163c stands out. Situated in the habitable zone of its star, it potentially offers the right conditions for supporting life. This planet is much more than a mere point in the cosmos. It represents a critical piece in solving the profound mystery of whether humanity stands alone in the universe. The discovery of it opens up a lot of learning opportunities and could inspire more people to become interested in astronomy. Teachers can add this new information to their lessons, allowing students and the public to experience the excitement of new space discoveries. The idea of planets like it, which might support life, makes space science feel more real and helps people see how things like astrophysics affect the world around them. This kind of discovery also helps spread the word about science through the news and other media, making astronomy more exciting and easier to understand for everyone. The exploration of it is just beginning. As more data is collected, plans for future missions are taking shape, aiming to study the planet even more thoroughly. These missions are expected to verify existing findings and delve deeper into the planet's atmosphere. Utilizing advanced techniques, such as enhanced imaging and spectroscopy, researchers aspire to obtain a more detailed understanding of the planet's surface and its climatic conditions. These efforts are crucial in moving closer to determining whether it could indeed support life. The exploration of it has spurred scientists to formulate new theories and models that enhance understanding of distant planets. By analyzing data from the observatory, astronomers are re-evaluating the criteria that make a planet habitable. Factors such as unique chemical compositions and potential geothermal activity are now considered vital in supporting life forms, potentially differing significantly from those on Earth. The insights gained from it are being integrated into broader space research, suggesting that humanity may be on the cusp of discovering novel environments capable of sustaining life, thereby transforming conventional perceptions of life in the universe. The star Betelgeuse, known for its brilliant luminosity easily visible to the naked eye, experienced a significant decrease in brightness that captured global attention. The dimming was not a minor fluctuation. Rather, it represented a sharp decline from the usual luminosity levels observed. Historical data indicated that Betelgeuse's brightness had varied in the past, but the extent and speed of this recent dimming were extraordinary, sparking curiosity and concern among the astronomical community. Observatories across the world directed their telescopes towards the star, speculating whether this pronounced change could signal an impending major event, perhaps even a precursor to a supernova. Given Betelgeuse's status as one of the most closely monitored red supergiants, this unusual phenomenon presented a unique opportunity for scientists to deepen their understanding of the life cycle and characteristics of such massive stars. This event not only heightened scientific inquiry, but also underscored the dynamic and sometimes unpredictable nature of stellar behavior. However, the significant dimming of Betelgeuse was not the most astonishing aspect of the event. The potential of witnessing a supernova, an event that many consider a once-in-a-lifetime opportunity, stirred excitement among people worldwide. The diminishing brightness of Betelgeuse led astronomers to speculate whether they were on the brink of observing such a colossal explosion. Yet, accurately determining the size and distance of Betelgeuse presented significant challenges. The star's tendency to fluctuate in size complicated efforts to obtain precise measurements. Furthermore, a phenomenon known as limb darkening, where the star's light appears to fade around its edges, added difficulty in accurately assessing its true dimensions. These challenges underscored the complexities involved in studying such unpredictable celestial bodies. In addition to the challenges of measuring Betelgeuse's size, the exact distance of the star from Earth remains uncertain. Estimates place it between 430 and 724 light-years away, though advancements in technology could refine these figures in the future. Despite these obstacles, modern telescopes have uncovered fascinating details about Betelgeuse. Notably, the star is encircled by at least 6 layers of material it has expelled over time. These ejected shells provide crucial insights into how stars lose mass and the processes occurring at various phases of a star's life cycle, enhancing the understanding of stellar evolution. Next, we turn to a star that might light up the sky. Betelgeuse could light up the sky. Looking into the future, Betelgeuse could explode in a massive supernova, completely transforming the night sky. A supernova happens when a star runs out of fuel and blows up, releasing an enormous amount of energy. In Betelgeuse's case, as it burns through lighter elements like hydrogen and moves on to heavier ones like helium, carbon, and eventually iron, its core becomes unstable. When the core can no longer support the star's weight, it collapses, triggering the explosion. The supernova could be so bright that it might outshine all other stars in the sky combined, even being visible during the day. However, this amazing event wouldn't pose any danger to Earth, despite Betelgeuse being around 600 light-years away. Any radiation or particles from the explosion would be too weak by the time they reached us. So, while Earth won't be affected, stargazers will be treated to an incredible view, and scientists will have the rare chance to study such an event up close. This distance gives us a perfect opportunity to learn more about supernovas without any risk. But the story doesn't end there. Betelgeuse is a unique case, offering a rare glimpse into the life of a star nearing the end of its life. Like other stars, it started by fusing hydrogen in its core, turning it into helium and releasing huge amounts of energy. As Betelgeuse aged, it used up all its hydrogen, which led to a new phase in its life. At this point, the star began fusing heavier elements, a crucial stage that changed its size and energy output. This is why Betelgeuse is now a red supergiant. Its surface has cooled, its size has increased, and its brightness has become more unpredictable. But even heavier elements like iron have come into play. Unlike the earlier fusion processes, creating iron uses up energy instead of producing it. This means Betelgeuse is losing its balance. Without energy to push outwards, gravity starts to pull the star inward, leading to a collapse. This sets the stage for a supernova, one of the most dramatic events in the life of a star. When Betelgeuse finally runs out of fuel, its outer layers will explode, briefly outshining entire galaxies. This spectacular explosion will not only mark the end of Betelgeuse, but also help seed the universe with new stars and planets by scattering heavier elements across space. By studying Betelgeuse, astronomers get a better understanding of how stars evolve and die, shedding light on the bigger processes that shape our universe. Yet, this is just the beginning. As new technologies like the James Webb Space Telescope come into play, scientists will be able to study Betelgeuse and other red supergiants in even more detail. These next-generation telescopes will help us learn more about how stars lose mass and what exactly happens before they explode. The future holds many more discoveries about the life and death of stars, paving the way for a better understanding of the universe's most powerful events. For the first time, we had clear proof that black holes really exist. This wasn't just a blurry image. It was a sharp and detailed photo showing the black hole's shadow against bright, glowing gas. The light that tried but failed to escape the black hole made the event horizon, its boundary, visible to us. In our own Milky Way galaxy, hidden from view, there could be over 100 million black holes scattered across its vast space. Let's explore this fascinating idea and see what it tells us about our universe. The Milky Way is a huge spiral of stars, gas, and dust. Within this swirling galaxy, there are many hidden black holes. Scientists believe that there could be more than 100 million of these cosmic objects, though finding them is not easy. Black holes don't emit light or radiation that we can directly detect. We know they exist because of their strong gravitational pull, which affects nearby stars and gas. This makes black holes the ultimate invisible objects in the universe. But here's something even more interesting. The fact that our galaxy could be filled with black holes changes how we understand the universe. It impacts our knowledge of how stars evolve, how galaxies move, and even the eventual fate of everything. When we talk about black holes, one of the main ideas is that they form from the remains of massive stars. Imagine a star much larger than our sun. As it runs out of fuel, it explodes in a supernova, throwing off its outer layers. What remains is the core, which collapses under its own gravity. If this core is massive enough, it collapses into a point of infinite density, creating a black hole. There's more to black holes than just their creation. Mathematician Roy Kerr came up with a twist to the theory. He suggested that some black holes spin at incredibly high speeds. This rotation creates a thin, disc-like structure around the black hole, known as the ergosphere. In this region, even space and time start behaving in strange ways, dragged along by the spinning black hole. Still, this wasn't the most puzzling part. Things get even weirder when we talk about wormholes. Imagine space-time as a flat sheet. Normally, we move from one point to another on this sheet. But what if we could fold the sheet, bringing two distant points closer? A wormhole would be like a tunnel connecting these points, a shortcut through space. This idea comes from Einstein's theory of general relativity, which says space-time can bend or fold under extreme conditions, like near black holes. But wormholes, if they exist, might collapse the second anything, even a single particle, tries to pass through them. Despite these challenges, wormholes are still a hot topic among scientists. They make us wonder about the universe's deepest secrets. Could they one day allow us to travel between stars or even between galaxies? Now, let's dive into the mysteries of space with a new theory: string theory's extra dimensions. This theory tries to bring together Einstein's ideas about gravity with quantum theory, which explains how the tiniest particles work. Superstring theory has a simple but amazing idea. What if the smallest particles, like electrons and quarks, aren't tiny dots, but instead are little vibrating strings? Each string vibrates in a way that gives particles their properties, kind of like how different notes come from different vibrations on a guitar string. And here's the twist. Superstring theory also suggests that the universe has more than the 4 dimensions we know, 3 of space and 1 of time. It says there might be 10 dimensions, with the extra ones being so small we can't see them. These extra dimensions could explain some mysteries in physics, like why gravity is much weaker than other forces. In this theory, gravity seems weaker because it spreads out over all 10 dimensions, while other forces stay in the dimensions we can easily observe. But this isn't even the biggest question. Could these extra dimensions hold the key to solving even more mysteries about how the universe works? The Parker Solar Probe is currently the fastest spacecraft we've ever built, traveling at an incredible speed of 700,000 kilometers per hour. Even with that speed, it would still take more than 6,500 years to reach Proxima Centauri, the closest star to us after the Sun. This example really shows how unbelievably vast space is. It reminds us that even our most advanced technology is still just scratching the surface when it comes to exploring the universe. While ideas like warp drives and folding space sound exciting, the reality is much different right now. We live in a universe where the enormous distances between stars and planets make us realize how small and limited we are. Our fastest spacecraft and our wildest dreams about bending space and time are still held back by the technology we have today and what we currently understand about physics. But this isn't the most frustrating part. It's the very challenge of these vast distances that pushes us forward. Every bit of progress we make builds on what came before. Each new discovery or invention brings us a little closer to our goal of exploring the stars. One generation inspires the next, and slowly but surely, we push the limits of what's possible. Right now, as we focus on Mars and beyond, we're reminded of how difficult it is. The idea of sending humans to Mars once seemed like science fiction, but now it's something we're working towards, thanks to the hard work of space agencies and inventors around the world. Mars represents the next big step in our journey into space, a challenge that inspires us to keep exploring and to reach for even more distant places. But this isn't the only hard part. Our goal of reaching Mars is not just about finding a new place to live. It's about seeking new adventures. It shows our natural human curiosity and drive to explore and understand the world around us. It's about pushing the boundaries of what we can achieve with our technology and our imagination, dreaming of a future where the stars are not just distant lights in the sky, but places we can visit. This same spirit is driving the exciting ideas around interstellar travel. Scientists and engineers are looking into concepts that used to only exist in science fiction. Things like traveling faster than light or bending space-time. These ideas aren't just fantasies. They represent our desire to break through the limits of what we know and to imagine what might be possible in the future. But that's not even the most inspiring part. As we get closer to these new challenges, the importance of missions like the Parker Solar Probe becomes even clearer. These missions don't just help us learn more. They push us to think bigger and dream further. They remind us that the universe is there to be explored, not just observed. It's an open invitation to the next great chapter in human history. As we continue this journey, Mars and other distant worlds become symbols of our ability to overcome our limits. They push us to rethink what travel, life, and our place in the universe can look like. As we explore more, we open the door for future generations to live and thrive in space, turning today's science fiction into tomorrow's reality. Strong radiation from nearby stars can strip away the protective atmosphere of planets like Proxima b, which orbit very close to their stars. This is a big problem because an atmosphere is not only important for supporting life, but also for shielding the planet's surface from harmful cosmic and solar radiation. Without this protective layer, life would have a hard time surviving. To make things worse, small stars called M-dwarfs stay active for much longer periods than larger stars. This means that it might be exposed to these tough conditions for billions of years. The long exposure to solar radiation can make it difficult for life to start or continue on this planet. The constant bursts of energy from the star could prevent the planet from keeping a stable atmosphere long enough for life to develop. On top of that, intense particles from Proxima Centauri might slowly destroy any protective ozone layer the planet's atmosphere might have, if it even has one. Without this ozone layer, the planet would be exposed to dangerous ultraviolet light, which could damage the DNA of any living organisms trying to survive there. This adds another challenge for life to overcome. Despite these difficult conditions, there is still a small bit of hope. Life on Earth has been found in extreme environments, which makes scientists wonder if life could also find a way to exist in places like this. This planet remains an important focus for exploration, and every new discovery brings us a step closer to understanding not just other planets, but the tough and adaptable nature of life itself. Advanced tools like the James Webb Space Telescope, with its special instruments like the Near-Infrared Spectrograph, NIR-SPEC, and the Mid-Infrared Instrument, MIRI, are changing how we study faraway planets. These are not just ordinary telescopes. They are like super high-tech machines that break light down into its different parts. This method, called spectroscopy, allows scientists to find specific gases and other elements in the atmosphere of planets like Proxima b. If you found our journey through the cosmos intriguing, consider the possibility of life on Gliese 163c. Could its discovery prove we are not alone in the universe? Don't forget to like, subscribe, and share your thoughts in the comments below.